Welcome back, everybody. Today, we're going deep on Amazon Web Services.
AWS for sure.
AWS, right. You're already pretty familiar with cloud computing basics.
Right.
So we dug into some AWS Academy training materials
Yeah,
and really wanted to uncover the insights that matter most to you.
exactly. These materials go way beyond just the basics. We're talking cost management, security, even real world case studies. So,
Wow.
yeah, we'll see how AWS is really a lot more than just renting servers. It's a whole new way to think about building and deploying technology.
I'm really intrigued by this idea of uh, infrastructure as software.
Yeah,
It sounds like a huge shift from traditional IT, doesn't it?
it really is. I mean, think about it. No more upfront costs for servers that you might not even end up using fully.
Right.
With AWS, you only pay for what you need,
True.
just like a utility bill.
Oh, I see.
And because AWS operates on such a massive scale, they can offer lower prices,
So it's kind of like a bulk discount.
Exactly.
So
Yeah.
instead of buying a whole data center,
Right.
I can basically just rent the specific components as I need them.
Precisely. And that brings us to one of the biggest benefits, which is flexibility.
Yeah.
Let's say you need more processing power for a big project, right?
Mm-hmm.
You can scale up instantly.
Wow.
And then when the project's done, you just scale back down and you stop paying for what you don't need.
Oh, that makes a lot of sense.
Yeah, no more guesswork and waste like you had with traditional infrastructure planning.
Yeah, it's like the difference between buying a whole grocery store versus just the ingredients you need for dinner tonight.
Exactly.
I remember reading that case study about Delaware North.
Yeah.
Didn't they save millions of dollars by moving to AWS?
They did. They saved 3.5 million, which really shows you the impact of this model in the real world. Now,
Yeah.
one thing that can be a little confusing about AWS
Okay.
is all the different service models they have. There's IaaS, PaaS, and SaaS.
Yeah, those acronyms can be a
Mhm.
bit overwhelming. I mean, do they all basically boil down to just renting different levels of infrastructure?
They're more like choosing different levels of service, kind of like with food. So
Right.
IN is like getting all the raw ingredients and cooking yourself.
Okay.
POS is like having a meal kit delivered, where it's all prepped.
Okay.
And then sauce is like just ordering takeout.
So the more service I want, the less I have to manage myself.
Exactly.
Makes sense.
And alongside these service models, you also have different deployment models. So cloud, hybrid, and on-premises. AWS gives you the option to blend traditional IT with the cloud, or if you want, go fully cloud native.
So it's really like a custom blend of IT solutions, however I want to do it.
Right, yeah.
Now I'm really curious about the actual AWS toolbox itself.
Yeah.
What kind of tools are we talking about here?
Think of AWS as a massive collection of services, and each one is designed to do a very specific task.
Mhm.
It's like a giant Lego set
Okay.
for building tech solutions. So, for example, if you're building a database app,
You might use EC2 for computing power, S3 for storing your data, and DynamoDB for the actual database.
so instead of buying individual servers and software licenses, I just pick and choose the services I need and connect them all together.
Exactly. And to help you navigate this massive toolbox, AWS offers something called the Cloud Adoption Framework,
Okay.
or CAF. It's a set of guidelines and best practices to help you plan your cloud migration and adoption.
So it's like having a roadmap for success in the cloud.
Yes, exactly.
Now, one thing that always comes to mind with cloud computing is security.
Right.
How does AWS address those concerns?
Security is definitely a top priority for AWS.
Okay.
They operate on something called a shared responsibility model,
Okay.
which means AWS secures the underlying infrastructure, the physical data centers, servers, networks.
Right.
But you, the user, are responsible for securing your applications and data
Okay.
within that environment.
That makes sense. It's like renting an apartment in a secure building.
The building management handles the overall security, but I'm responsible for locking my own door and protecting my belongings.
Exactly. And AWS provides a whole range of security tools to help you do that. One of the most important is IAM, or Identity and Access Management.
Okay.
So IAM basically lets you set up very granular permissions.
Mm-hmm.
So not everyone on your team has access to everything.
Right. So I can control who has access to what down to the individual service level.
Absolutely. And to further enhance security, AWS offers multi-factor authentication,
Oh.
or MFA.
Right.
This adds an extra layer of protection, requiring a second authentication factor, like a one-time code from an app or a hardware token.
So it's even harder for unauthorized users to get in, even if they somehow got a hold of my password.
Exactly. Yeah.
It seems like AWS has really thought this through, offering multiple layers of security. But with all this cloud convenience, it can't be free, right?
Mhm.
How does AWS pricing actually work?
Well, AWS offers a bunch of different pricing models,
Okay.
but the core concept is pay as you go. So you only pay for what you actually use.
Right.
They even have tools like the AWS pricing calculator
Okay.
to help you estimate your costs before you commit to anything.
That's helpful.
Yeah.
But I imagine with so many services and different options, pricing can get a bit complicated, right?
It can be, yeah.
Yeah.
AWS has different pricing models, like on-demand instances, which are kind of like paying for a taxi,
Okay.
and reserved instances, which are more like leasing a car.
Oh, I
And
see.
then there's spot instances,
Yeah.
which are kind of like a discounted ride share.
So I can choose a pricing model that aligns with how I actually plan to use the resources.
Exactly. Understanding these pricing models is really crucial for optimizing your cloud budget.
It sounds like AWS pricing is a bit like choosing a phone plan. So many variables to think about.
It is, yeah.
But with careful planning, it seems like I can tailor a solution that really fits my needs and my budget.
Definitely.
What about the global reach of AWS?
Mhm.
Does it really matter where my applications are actually hosted?
It absolutely does. But
Okay.
AWS has this global infrastructure with regions spread all over the world,
Wow.
kind of like continents, right? And within each region,
Hmm.
you have availability zones,
Mhm.
like controls. Choosing the right region for your apps can really affect performance, especially latency, which is basically how long it takes for your data to travel.
So if most of my users are in Europe,
Right.
I should probably choose a European region to minimize any delays they might experience.
Precisely. And then there are availability zones, which are basically physically separate data centers within each region.
Okay.
And those help ensure high availability. So if one data center has a problem,
Right.
your applications can basically just switch over to another availability zone.
Oh.
And that minimizes any downtime or disruption.
So it's like having a backup generator for my cloud applications.
Exactly.
That's good. Now let's talk more about Amazon VPC,
Yeah.
Virtual Private Cloud.
Mm-hmm.
It sounds like I can create my own private network within the AWS cloud, right?
That's right. It's like carving out your own little space within the cloud
Okay.
and setting up all the rules for how traffic flows in and out.
So it's like having my own private network
Yeah.
with my own IP address ranges and security configurations and all that.
Exactly. And you can even create subnets within your VTC, which are like smaller, isolated networks.
So it's like dividing my cloud house into different rooms for different purposes.
Exactly.
Uh,
And then to control how traffic flows between these subnets,
Mhm.
you use things called route tables.
Route tables, what are those?
Think of them like traffic signs for your network, you know?
Okay.
They basically tell the data packets where to go
Oh, I see.
based on their destination IP address.
So they help direct traffic to the right place within my VPC.
Exactly.
Okay.
And then to connect your VPC to the outside world,
Mm-hmm.
you use internet gateways or NAT gateways, depending on what you need.
Right, we discussed those briefly. Internet gateways provide a direct connection to the public internet, and NAT gateways allow instances in a private subnet to access the internet without having public IP addresses.
Yeah.
Right.
You got it.
It seems like VPCs are a really powerful way to control and isolate my cloud environment.
They are, yeah.
Now let's talk about Amazon EC2 again.
Right.
We talked about how it lets us create those virtual machines.
Yeah.
But I'm actually curious about the process of launching an instance.
Mm.
What are the key decisions involved there?
It's kind of like setting up a brand new computer.
Okay.
The first thing you need to do is choose an Amazon Machine Image, or AMI,
Okay.
which is basically a template that contains the operating system and other software for your virtual machine.
So it's like choosing the operating system for my computer, Windows or Linux.
Exactly.
Right.
And then you select an instance type. And that determines all the hardware specifications, like the number of CPUs, how much memory it has, the storage capacity. There are tons of instance types available, and they're each optimized for different things.
So if I need like a super powerful virtual machine for data analysis,
Right.
I'd choose an instance type with more CPUs and memory.
Right.
But if I just need something basic, like a simple web server, I could go with a smaller, less expensive instance type.
Exactly. It's all about choosing the right tool for the job.
Okay.
And then, of course, there's security. You need to configure security groups for your instances.
Right. We talked about security groups. They're like virtual firewalls that control the traffic coming in and out of my instances.
Exactly.
It sounds like setting up an EC2 instance is similar to setting up a physical server, but with a lot more flexibility and control.
Absolutely, yeah.
That's pretty amazing. It's like having a remote data center that I can control at my fingertips.
Mm-hmm.
But Are virtual machines the only way to run applications on AWS?
Not anymore.
Oh,
AWS is evolving beyond virtual machines, and we have things now like containerization and serverless computing.
okay, let's break down those terms. What exactly is containerization?
Okay, so think of containers like shipping containers.
Yeah.
You pack everything your application needs, code, libraries, dependencies, all into this container. And then that container can run anywhere.
Okay.
It's completely self-contained.
So it's like a lightweight, self-sufficient package that can be easily moved and deployed across different environments.
Exactly. And because containers share the operating system kernel of the host machine, they're much lighter and faster than traditional virtual machines.
So they start up quickly, consume fewer resources, which can lead to cost savings and more agility.
Exactly. They're getting really popular for building and deploying modern cloud applications.
Sounds like a powerful tool for streamlining the whole development process.
It is.
But how do you manage all those containers? Especially if I have lots of different applications running.
That's where container orchestration platforms come in. And AWS offers two main services for that, Amazon ECS and Amazon EKS.
Okay, tell me more about those. What do they actually do?
So Amazon ECS, which stands for Elastic Container Service,
Okay.
it's a fully managed container orchestration service that makes running Docker containers on AWS super easy.
Okay.
It handles things like container deployment, scaling, networking, and more.
So it's like a central control panel for my containers. I can manage their entire life cycle.
Exactly.
Okay.
And then you have Amazon EKS, which is Elastic Kubernetes Service.
Okay.
And that's a managed Kubernetes service that lets you run Kubernetes on AWS.
Kubernetes. I've heard that term, but I don't really know what it is. Is that another container orchestration platform?
It is, yeah. Kubernetes is an open source container orchestration platform, and it's super popular.
Okay.
It's known for all these advanced features, but it can be pretty complex to manage. So that's where EKS comes in. It takes care of all the infrastructure and the management tasks, so you can just focus on deploying and managing your Kubernetes applications on AWS.
So it's like having a team of Kubernetes experts managing my clusters for me.
Exactly. EKS really simplifies running Kubernetes on AWS. It's a powerful option for running containerized apps at scale.
Now let's go back to serverless computing for a minute.
Okay.
We talked about how it lets you focus only on writing your code, with AWS handling the infrastructure and all that.
Right.
Can you explain a bit more about how serverless computing actually works?
It's all about event-driven architecture. So you write your code as functions,
Okay.
and then those functions are triggered by certain events, like an HTTP request, a file upload, or a message in a queue.
So instead of running my code on a server all the time, I just tell AWS what should make it run, and it takes care of everything else.
Exactly. And you only pay when your code is actually running. It's super efficient, especially for applications with workloads that are, unpredictable.
It's like having a light bulb that only turns on when I flip the switch, and I only pay for the electricity used while the light is on.
Precisely. AWS Lambda is the key service for serverless computing.
Okay.
So you just upload your code to Lambda and it handles everything else, scaling, load balancing, security, the whole 9 yards.
Wow.
You can even chain together multiple Lambda functions to create really complex workflows.
Serverless computing sounds like a real game changer for developers.
It really is.
They don't have to worry about any of the infrastructure stuff.
It's all handled for you.
We've covered a lot in this segment, from security and infrastructure to containerization and serverless computing. It's clear that AWS offers a huge range of tools and services, allowing developers and businesses to build and deploy amazing things in the cloud.
It's really quite impressive.
But we've only scratched the surface.
Oh yeah, there's a ton more to explore.
There's a whole world of services and capabilities, each one designed to address very specific needs and challenges. And we're excited to continue our deep dive into AWS and uncover even more of its secrets. Stay tuned for the next segment, where we'll delve into storage options, databases, and much more.
Welcome back to our deep dive into AWS. Last time we were talking about how AWS provides the secure foundation for your cloud infrastructure.
Right, we talked about the shared responsibility model.
Right.
And how AWS handles the security of the cloud, like the physical data centers, networks, all that.
Exactly.
But what about securing our own applications and data within that environment? What can we actually do?
That's where security and the cloud comes into play. And it's a super important part of working with AWS. We have to be proactive
Okay.
about securing our configurations, managing access keys, and really just implementing the right security measures within those cloud environments.
So it's a multi-layered approach.
Absolutely.
Yeah.
And AWS gives us a bunch of different tools and services to help us build those layers. We touched on IAM briefly, but let's dig a little deeper into that. IAM is like the control center for managing who has access to what in your AWS world.
Okay, so we talked about how it allows us to set up permissions, so not everyone has access to everything.
Right.
But how does that actually work? What are the mechanisms that it uses?
So IAM is all about this principle of least privilege,
Okay.
meaning you only give users the permissions they absolutely need
Okay.
to do their jobs. This helps minimize any risk of data leaks or unauthorized changes, right?
Right.
To do this, IAM lets us create users, groups, and roles, each with their own set of permissions.
So users are like individuals or applications that are accessing the AWS resources.
Right.
Groups are collections of users, so you can manage permissions for like whole teams.
Exactly.
But what about roles? Still a little fuzzy on those.
Okay, so think of roles as these temporary permission badges that you give to users or apps.
Okay.
So let's say you have an application that needs to get into an S3 bucket,
Hmm.
but only for a very specific task, right? Instead of giving the application full access to the bucket all the time,
Right.
you create a role with just those very specific permissions.
Oh, okay.
And you assign it to the application only when it actually needs access.
I see.
And then once the task is done, you take the role away.
So it's all about limiting the risk.
Yes.
By controlling how long those permissions last and what they apply to.
Exactly. It's about reducing that potential attack surface and making sure that only the right things have access to sensitive resources at the right times.
It's like giving someone a temporary key card that only works for one room for a certain amount of time.
Exactly, yeah. And then on top of that, AWS has multi-factor authentication, or MFA.
Right. MFA.
Yeah,
That adds an extra layer of protection by requiring a second verification factor,
exactly.
like a code from an app or a hardware token
Right.
on top of your password.
Yeah, it makes it way harder for anyone to get in, even if they steal your password somehow.
Yeah.
Now let's change gears a little bit and talk about the global infrastructure of AWS again. We mentioned regions and availability zones,
Right.
but I think it's worth diving a little deeper into how they affect your applications.
Yeah, I'm curious about that.
So it's all about minimizing latency and maximizing availability.
Okay.
Remember, latency is how long it takes for data to travel between different points.
Right.
So if you have users in Europe, for example,
Mm-hmm.
and your application is hosted in the US,
Yeah.
there's going to be some noticeable delay because of how far that data has to travel.
So choosing the right region for my application is super important for making sure my users have a good experience, right?
Exactly.
Like choosing a server that's closer to your target audience
Right.
if you're playing online games or something.
Right.
You don't want that lag.
Exactly. And then you have availability zones,
Right.
which are basically physically separate data centers
Mm-hmm.
within each region.
Okay.
And those are there to make sure you have high availability. So if one data center has an issue,
Okay.
your applications can just switch over to another availability zone
Oh.
without any interruption.
So it's like having redundant servers in different places, so if one goes down, the others can pick up the slack.
Exactly. AWS is designed to be really resilient, making sure your applications stay up and running even when unexpected things happen.
That's reassuring, for sure.
Yeah.
Let's talk more about virtual private clouds.
VPCs.
Yeah, VPCs.
Oh,
We
yeah.
compared them to creating rooms within your cloud house
Mm-hmm.
before,
Right.
but I'm still a little confused about the specifics.
So VPCs basically give you full control over your network environment in AWS. You're carving out your own little section of the AWS cloud
Okay.
and setting up all the rules for how traffic moves around within your applications.
So it's like having my own private network within the cloud
Yeah,
with my own IP addresses and security configurations, all that.
exactly. And within your VPC, you can create subnets,
Okay.
which are like smaller, isolated networks
Mhm.
that you can use to segment your applications and resources even further.
So it's like dividing those rooms in my cloud house into different areas, like a living room and a bedroom.
Exactly.
Okay. And then to control the traffic between these subnets, you use what are called route tables.
That's right. Think of route tables like traffic signs for your network.
Okay.
They basically define the rules for how data packets move around in your VPC, telling them which subnet to go to based on their destination IP address.
So they're like a traffic controller directing the data to the right place.
Exactly. And to connect your VPC to the outside world, you use internet gateways or NAT gateways, depending on what you need.
Right, we talked about those.
Yeah.
Internet gateways are a direct connection to the internet, while NAT gateways allow instances in private subnets to access the internet without needing public IP addresses.
Got it.
It's all about having that control over your network traffic and security.
It is, yeah.
VPC seem like a really powerful way to control and isolate my cloud environment. Let's talk about Amazon EC2 again.
Okay.
We talked about how we can use it to create virtual machines, but I'm interested in that process of actually launching an instance. What are the big decisions I need to make?
So launching an EC2 instance is kind of like setting up a new computer.
Okay,
First, you got to pick an Amazon Machine Image, or AMI,
great.
which is basically a template that has the operating system and other software that your virtual machine will use.
So like choosing if my computer will run Windows or Linux.
Exactly.
Gotcha.
Then you choose an instance type, which defines the hardware specs of your virtual machine. Things like how many CPUs, how much memory and storage it has, and there are lots of different instance types to choose from, and they're all optimized for different things.
So if I need a super powerful virtual machine for like data analysis, I'd pick an instance type with more CPUs and memory. But if I just need a basic web server, I can pick something smaller and less expensive.
Exactly. You got to pick the right tool for the job. And then, of course, security is crucial. You got to set up security groups for your instances.
Right, those security groups act like virtual firewalls, right?
Yeah.
Controlling what traffic can come in and out.
Yes,
It's like having a security guard check everyone's ID at the door.
precisely. Now, we can get a bit more advanced with EC2, talking about the instance lifecycle and different storage options.
Okay, what about the life cycle of an EC2 instance? What are the different states it can be in?
The instance lifecycle basically refers to the different stages your instance goes through from when it's created to when it's terminated.
Okay.
It starts in a pending state while AWS gets everything ready.
Okay.
And once it's all set up, it moves to a running state and you can start using it.
So when I launch an instance, it takes a little time to actually become active.
Right.
And what happens if I decide I don't need that instance anymore?
You can stop the instance, which basically releases the resources and stops the billing.
Right.
But it keeps all your data safe. It's like putting your computer to sleep.
Okay.
It's still there, but it's not using any resources. If you need it again, you just start it back up.
That's handy.
Yeah.
So stopping an instance is a good way to pause it temporarily without losing anything.
Exactly.
But what if I want to get rid of the instance for good?
Then you terminate the instance, and that completely deletes it along with all the data. It's like wiping your computer and throwing it away.
So it's important to have backups before you terminate anything, because once it's gone, it's gone.
Exactly. You can't undo termination, so make sure you understand what you're doing before you hit that button.
Now, what about storage options for these EC2 instances? I know there are different types, but how do they work with EC2?
Okay, so there are two main types of storage you can use with your EC2 instances: Instance Store Volumes and Amazon EBS Volumes.
All right.
Instance store volumes are temporary storage that's physically attached to the computer running your instance.
Okay.
They're really fast, but the data is lost if the instance is stopped or terminated. It's like the RAM in your computer.
So if I turn off my computer, the data in RAM is gone.
Exactly.
Okay.
But Amazon EBS volumes are different. They're persistent storage that's independent of the instance.
So the data is safe, even if I stop or terminate the instance.
That's right. EBS volumes are designed to be durable and persistent, so they're good for things like operating systems, applications, and important data.
So it's like having an external hard drive that I can attach to my virtual machine.
Exactly.
Even if I disconnect the hard drive, the data is still there.
Right.
Okay. And you mentioned there are different EBS volume types.
Yeah, you can choose from different types depending on your performance and cost needs.
So some are faster, some are more cost-effective.
Exactly. AWS has a bunch of options to choose from depending on what you need. Now let's talk about containerization and serverless computing a little more in depth.
Okay, we talked about containers before and how they're like shipping containers, packaging up everything an application needs.
Right.
But how are they different from virtual machines, really?
Containers are like lightweight, portable packages.
Okay.
And they have everything an application needs to run,
Mm-hmm.
but they share the operating system kernel of the machine they're running on. So they're way more efficient than virtual machines.
Right, because virtual machines each have their own operating system.
Exactly. This means containers start up faster, use less resources, and can be deployed much quicker.
So it's cheaper and faster to use containers.
Exactly. They're becoming super popular for building modern cloud applications.
They seem like a great way to streamline development and deployment.
They are.
But how do you manage a bunch of containers, especially when you have multiple applications running?
That's where container orchestration platforms come in.
Okay.
And AWS has two main services for that: Amazon ECS and Amazon EKS.
Okay, tell me about those.
So Amazon ECS stands for Elastic Container Service.
Mm-hmm.
It's a fully managed service that makes running Docker containers on AWS super easy.
Okay.
It handles things like deployment, scaling, networking, all that.
So it's like a control panel for all my container where I can manage their life cycle and everything.
Gemaakt.
Okay, cool. And what about Amazon EKS?
So EKS stands for Elastic Kubernetes Service. It's a managed Kubernetes service that lets you run Kubernetes on AWS.
Kubernetes. I've heard that term, but I'm not really sure what it is.
Kubernetes is an open source container orchestration platform that's really popular these days.
Oh, I see.
It has a ton of advanced features,
Okay.
but it can be pretty complex to manage.
Right.
So that's where EKS comes in. It takes care of the hard stuff so you can focus on your applications.
So it's like having Kubernetes experts managing my clusters for me.
Yeah.
So I don't have to worry about all the technical details.
Exactly. EKS makes running Kubernetes on AWS much simpler, and it's a powerful choice for those bigger, more complex applications.
Now let's go back to serverless computing for a minute.
Okay.
We were talking about how you only have to focus on writing code, and AWS takes care of all the infrastructure.
Right.
Can you explain a bit more about how that actually works?
So serverless computing is based on this thing called event-driven architecture.
Okay.
So you write your code as functions, and then those functions are triggered by certain events, like an HTTP request, a file upload, or maybe a message in a queue.
So my code isn't running all the time on a server. I just define what events should make it run, and AWS does the rest.
Exactly. And you only pay when your code is actually running.
Okay.
It's really efficient, especially for applications that have unpredictable workloads.
Like that light bulb analogy we were using before.
Exactly.
Only paying for the electricity when the light's on.
Precisely. AWS Lambda is the key service for serverless computing. You upload your code to Lambda and it takes care of everything else. Scaling, load balancing, security, everything.
That's awesome.
Yeah. And you can even chain a bunch of Lambda functions together to create complex workflows.
It sounds like serverless computing is a game changer for developers.
It really is.
No more worrying about infrastructure, just the code.
Yeah.
We've gone over a lot of ground here, from security and infrastructure to containerization and serverless computing. It's clear that AWS has tons of tools and services to help anyone build innovative things in the cloud.
It's pretty remarkable how much they offer.
Yeah.
But we've only scratched the surface.
There's so much more to explore.
Definitely.
A whole world of services and capabilities, each designed to address certain needs and challenges.
Right.
We can't wait to keep going with our deep dive into AWS and discover even more of what it can do. Stay tuned for the next part, where we'll be diving into storage options, databases, and lots more. Welcome back to the deep dive. We're wrapping up our exploration of Amazon Web Services.
That's right.
And this time we're going deep into the world of databases.
Exactly. And just like with everything else in AWS,
Right.
there are so many different database services to choose from.
Yeah, I know AWS offers a lot of options. Everything from traditional relational databases to those newer NoSQL databases,
Yeah.
even data warehousing. It's kind of overwhelming, to be honest.
It definitely can be. But the important thing is to understand the core differences between those database types
Okay.
and know when to use each one. You got to pick the right tool for the job.
Right, right. So let's start with the basics.
Yeah.
What are relational databases?
Yeah.
And why are they still so popular?
Relational databases have been around forever. They're based on the relational model where data is organized into tables with rows and columns.
Okay, like a spreadsheet.
Exactly, like a spreadsheet.
Oh,
And this structure makes sure that your data is consistent and stays accurate.
okay.
So relational databases are great for applications where accuracy and reliability are super important.
So if I'm building an application that needs like strict data validation
Right.
and clear relationships between different pieces of data,
Mhm.
a relational database is probably the way to go.
Exactly. Things like financial transactions, customer orders, inventory management, all those things where you can't afford to have any mistakes in your data.
Right.
And AWS has this managed relational database service called Amazon RDS.
Yeah, we touched on that earlier.
Yeah.
It sounds really convenient.
It is. It makes setting up, operating, and scaling your relational databases in the cloud super easy.
What's the benefit of using RDS versus just setting up a database on my own virtual machine?
With RDS, you don't have to worry about any of the infrastructure. You just choose your database engine, configure your instance size, set up your storage, and RDS handles everything else. Backups, patching, scaling, high availability, all of it.
So it's like having a team of database administrators working for me.
Right?
And I don't have to hire or manage them myself.
Exactly.
Wow, and RDS supports a bunch of popular database engines, right?
It does. MySQL, PostgreSQL, Oracle, SQL Server, you name it.
That's a lot.
It is.
Okay, so what about these NoSQL databases I keep hearing about?
Yeah.
Are they like a replacement for relational databases?
NoSQL databases are a completely different type of database. They're designed for specific use cases where relational databases aren't a great fit. They often give up some of the strict consistency of relational databases,
Mhm.
but in exchange, they get more flexibility, better scalability, and improved performance.
Okay, so when would I use a NoSQL database instead of a relational database?
Think of things like storing huge amounts of unstructured data, building highly scalable web apps, or handling data that's constantly changing in real time. Those are all good use cases for NoSQL databases.
So if I'm building like a social media platform that needs to support millions of users and tons of data,
You're right.
a NoSQL database might be better than a relational database.
Exactly. And AWS has a bunch of different NoSQL database services, each one optimized for different use cases.
See, this is where it gets a bit overwhelming again. Can you give me some examples of those NoSQL database services?
Yeah, so one of the most popular NoSQL databases is Amazon DynamoDB.
Okay, I've heard of that.
It's a key value store,
Okay.
and it's incredibly fast, scalable, and fully managed. It's perfect for applications that need low latency, high throughput, and can handle massive amounts of data.
Okay, key value score. Can you explain what that means?
It's pretty simple. Imagine a dictionary where each word is a key,
Okay.
and its definition is the value. So in DynamoDB, you store data as these key value pairs,
Okay.
where the key is a unique identifier and the value is the data that goes along with that key. It's a straightforward way to store and retrieve data.
So if I'm scoring user profiles and I want to retrieve them based on a unique user ID,
Right.
DynamoDB would be a good fit.
Perfect fit. And it's serverless, so you don't even have to think about managing any servers. DynamoDB takes care of it all.
That's pretty cool. It seems like NoSQL databases are all about flexibility, scalability, and performance.
They are.
But does that mean they don't care about data integrity and consistency?
They do, but it's a bit different. They often trade off strict consistency for better performance and scalability.
Okay.
But it doesn't mean they completely ignore data integrity. Different NoSQL databases have different consistency models
Oh, I
to
see.
fit different needs. DynamoDB, for example, allows you to choose the level of consistency you need for your application.
So it's not like a one-size-fits-all thing.
Exactly. And it's important to remember that NoSQL databases aren't all the same.
Okay.
There are document databases, graph databases, column family databases,
Wow.
each with their own strengths and weaknesses.
Can you give me some examples of those other types of NoSQL databases?
Sure, Amazon Document DB is a fully managed document database service that works just like MongoDB. It stores data in these JSON-like documents,
Yeah.
which are really flexible and self-describing.
Okay.
So it's a good choice for content management systems, mobile apps, and other applications where your data is naturally structured, like documents.
So if my data looks more like a collection of objects with their own sets of attributes,
Right.
a document database might make more sense.
Exactly. And then you have Amazon Neptune, which is a fully managed graph database service. Graph databases are great at storing and querying relationships between different entities.
Relationships between entities. Can you give me an example of that?
Yeah. Think of a social network, right? You have
Right.
users, posts, and connections between users. A graph database can easily store all that and answer questions like, who are this user's friends? Or what are the most popular posts?
So graph databases are good for understanding those complex relationships between data points.
Exactly. And then you have column family databases like Amazon Key Spaces. They're optimized for writing large amounts of data and then reading it back quickly. They're great for things like time series data analysis, IoT sensor data, and stuff like that.
So if I have a bunch of sensors collecting data
hmm
and I need to analyze it in real time,
Right.
a column family database might be the right choice.
Exactly. The best NoSQL database really depends on what you need it to do and the kind of data you have.
So many options.
There are.
It sounds like NoSQL databases are a great alternative to relational databases for certain things.
They are.
But what about data warehousing? How does that fit in?
Data warehousing is all about analyzing huge amounts of data. To gain insights and make better decisions for your business, it's like a central hub for all your business data,
Right.
where you can do those complex queries and create reports to understand trends, see patterns, and basically make smarter decisions.
So it's like having a giant data lake where I can gather all my data and use powerful tools to analyze it.
Exactly. And AWS has this fully managed petabyte scale data warehouse service called Amazon Redshift.
Petabyte scale. That's a lot of data.
It is.
Wow.
Redshift can handle tons of data,
Okay.
so you can easily analyze terabytes, even petabytes of data.
So if I have data coming in from a bunch of different places, like my website, my CRM system, my marketing tools,
Mhm.
I can use Redshift to bring it all together and analyze it to, say, understand my customers better,
Right.
improve my marketing, make my business run smoother.
Exactly. Redshift is a super powerful tool for anyone who needs to analyze lots of data and make sense of it.
This has been a really cool journey into the world of AWS databases. We've covered everything from those traditional relational databases to the newer NoSQL databases and even data warehousing.
We've covered a lot.
It's amazing how many options there are,
There are.
and each one has its own strengths and weaknesses.
Choosing the right database service is super important, and it all comes down to what you need it to do.
And luckily, AWS has a bunch of resources to help you make those decisions.
They do.
They've got documentation, tutorials, and expert support if you need it.
Mm-hmm.
So as we finish up this deep dive into Amazon Web Services,
Yeah.
I want to leave you with this.
Okay.
With all this knowledge and all these powerful tools at your disposal,
Yeah.
what amazing applications will you build? The possibilities are really endless.
I think you're right. The cloud has made all these incredible technologies available to everyone. And with AWS leading the charge, the future of innovation is brighter than ever.